So in the previous video, guys, we spoke about hydrogen forming one bond between another hydrogen atom to form a hydrogen molecule, an oxygen molecule containing a double bond, and a nitrogen molecule containing a triple bond. Now remember, each bond involves 2 electrons. So therefore, in the case of the oxygen double bond, it would be 4 shared electrons between the 2 oxygen atoms in the molecule. And in the case of the nitrogen molecule, it would be 3 bonds with 6 shared electrons. Now, what is really important is that you realize that those bonds you can think of like a rope. Okay, the more ropes you would have, the stronger or the greater the force you would need to break the ropes all at once. So in other words, a triple bond between the 2 nitrogen atoms would be the strongest, then the double bond, and then the single bond. Now, this bond strength is also related to the bond energy that's required. Remember, we said that the bond energy is the energy that's needed to break the bond. So it would need and require less energy to break the single bond between the 2 hydrogen atoms than the double bond between the 2 oxygen atoms versus the triple bond between the 2 nitrogen atoms. Now that we've covered this, let's go back to your notes and recap on what we've learned. Okay, so in topic 3.1, we learned about ionic bond formation, which is the transfer of electrons, which leads to the formation of ions and therefore subsequent electrostatic forces between the oppositely charged ions. Now we're looking at covalent bonding, which is another bonding model. But in this case, the atoms share electrons. Okay, our example that we looked at was the bond that occurs between diatomic molecules and specifically between hydrogen. Okay, so what we have here in this figure down below, here is our 2 hydrogen atoms. Okay, and you will see that there's blue and red arrows. The red arrows indicate attractive forces, whilst the blue ones indicate repulsive forces. Now, it's really important that you understand that we have both attractive and repulsive forces, but one of them can dominate for a certain part of the bond formation. When the atoms are far apart, as they are moving closer together, it's the attractive forces that is dominating. Once they form that bond and that they are at that minimum potential energy, and we get the formation of the molecular orbital, like we showed in the previous video, at that point, the repulsive forces and attractive forces are balancing out. Okay, so in other words, the attractive forces and the repulsive forces are the same in strength. The moment I try to force them closer together, what happens then? The repulsive forces become the dominant force, and therefore they will push one another apart, and therefore my potential energy graph increases exponentially. Okay, so what is also important to remember is that in the case of a covalent bond, neither atom will remove the electron from the other atom. Okay, they will share the electrons between them. So why does this bond formation take place? Because a hydrogen molecule is more stable and it has lower energy than the hydrogen atoms by themselves. Okay, then we can also talk about helium, why it does not form a molecular orbital. Why doesn't it form a molecular orbital? Yes, that's correct, because it has a completely full outer energy level, and therefore it doesn't have the need, and it's stable on its own, and it therefore doesn't form a bond. Now, when 2 atoms share electrons, they form what we call a covalent bond. The space that these shared electrons move in, we call a molecular orbital. Okay, and a covalent bond, we say, is a type of an intramolecular bond. Now, intra means within. So it's a bond that forms within a molecule, between 2 atoms within a molecule. Now, these definitions are quite important. We can't call an ionic compound a molecule, but we call covalent compounds molecules because it's a group of 2 or more atoms that are covalently bonded and that functions as a unit. A covalent bond is the sharing of at least one pair of electrons by 2 non-metal atoms, And an intramolecular bond is a bond which occurs between atoms within molecules. Now, this potential energy curve for hydrogen we also study. So I just want to remind you of a few things. There, the atoms are far apart, and the potential energy is almost zero because they are exerting no attractive forces on one another. As they are moving closer together, the attractive forces comes into play. Now they come closer and closer due to the attractive forces. When the potential energy is at a minimum, that's when I've reached the point which we call the bond length. And in the case of the hydrogen molecule, the bond length is 75 picometers. Okay, the bond energy is that value that I read off there. In the case of the hydrogen molecule, is 436 kilojoules per mole. You might say, but it's negative there. You said the bond energy is 436 kilojoules per mole. Okay, guys, this is important to take note of. Yes, it's a minimum there. That's the minimum energy. It has a minimum potential energy when that bond is formed. But remember what I said. We can't necessarily measure the energy that is released when two atoms bond, but we can measure the energy that's required to pull two atoms apart. And that's why we say the bond energy is a positive value of 436. Because if I want to pull these two atoms apart, where do I want to go? I want to go back up this hill to that place over there where they are at zero potential energy and far away from one another, exerting no forces on one another. So to get to that point, what do I need to do? I need to put in the energy that will take me up this hill. And that amount of energy is 436 kilojoules per mole. So the bond energy, the energy that's required to break this bond between the hydrogen molecules is 436 kilojoules per mole. Okay, so the rest of this discussion we have discussed before, and you can work through that. So I just want to affirm again that the distance between the two bonded hydrogen atoms are at their lowest potential energy is what we call the bond length. The energy required to break a bond between atoms is what we call the bond energy. And if the bond energy is greater, it must mean it's a stronger bond. And I want to remind you that a triple bond between two nitrogen atoms will be stronger than a double bond between two oxygen atoms will be stronger than a single bond between two hydrogen atoms. Okay, I want you to attempt the questions now and see that you answer them to the best of your abilities.